Alright, hello, this is going to be Solidworks CSWA practice problem 8.7. If you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. So now we're going to be starting with sweeps. Now sweeps are pretty annoying because it's not like extrudes where you just make a sketch and you extrude it. Now you need to make two sketches. One sketch is your profile and the other sketch is your path. The profile is a shape that you're going to be extruding along a path. Any path you want, which makes sweeps a very powerful tool. You can make like kind of these very curly snake extrusions, kind of like a rope. So anyway, let's make sure we have units as LMGS. Then we'll start sketching the front plane. And I'm going to work bottom to top, so let's go for a slot for now. You can see the bottom sweeps obviously in a slot shape. And let's center the bottom edge midpoint to the origin. Coincidence. And the distance between its arc center points is going to be 225. And the radius is going to be 110. Should be like this. And so that's your path. Now let's create our, let's exit sketch. Let's create our exit sketch. And let's create a new sketch in the right plane. And then let's make a circle like so. And then in the top view it says 40 typical for the circle. Every sweep is going to have a circular profile of the same diameter. And then this is a very neat tool. If you select the center point of the circle and then select the line, obviously using your control key, you get the pierce option. And I guess the most intuitive way to think about this is I guess like when you're a kid and you're trying to make bracelets, you put those little beads inside and the beads have like a hole in them and you put them through string. That's essentially what piercing means. And so now we have our profile and path, so we can go do our sweep, and it automatically selects the circle as a profile. Now we just gotta select this line for the path. Then you have your slot sweep. Select OK. So this is where we'll start everything. Now let's start a new sketch in the front plane. And I'm going to go straight ahead and do the next sweep. It kind of looks like a, I don't know, looks like pipes. But anyway, I think it will be useful to use a center line here to use the mirror tool. Oh, I did not make that vertical. Let me make that vertical. Vertical, okay. Wait, is this vertical? Yes, it's vertical. Alright. So we'll start with something like this. Goes to the head like this. And I'm not entirely sure if I need to do... Actually, no. It has to be two paths, right? You have the first part, like the bottom half that looks kind of like a bending pipe, and then the top half should be this straight pipe that's intersecting between them. And I think you can just draw the line in between the pipes. And it's perfectly fine if the second sweep intersects with the first sweep, because in SolidWorks the the rule is if you extrude inside of an extrude, it doesn't change the volume. It's the same volume, which is nice. So let's draw the first part. Ignore the top bar first. So let's mirror on the center line. Select OK. Let's add some dimensions here. So the dimension from this line to origin is going to be 475. And the total height from this point to this line is going to be 150. And then the total distance between these 2 points, the total width of the part is going to be 385. And I'm going to ignore the slot dimensions for now. Those are coming later. So let's add our sweeps first. Or not sweeps, sorry, fillets of 32 for the 2 corners. So has a midpoint equal line? Yes, that's fine. The only reason that warning came up is because this line right here is midpoint constrained with this, but changing the fillets of these corners is not going to affect that midpoint. So it's a needless warning. So there's your path, and then yes. And like before, you can draw the profile, like the circle, in your the right, or you can draw in the top. Just to shake things up, I'll draw it in the top this time. I don't want that. Let's exaggerate it. So let's click sketch. Let's go to the top plane. And you can vaguely see. You can vaguely see it's right here. Just gonna draw a circle like so. Its diameter is gonna be 40. And then I'm gonna make this control center point, control this point. I guess we'll make it coincident. Oh, actually, no. I want to make this point and this line pierce. No intersection found for the pierce point. No intersection found for the pierce point. I guess it'll be easier to do it in the right plane then. So I guess I'll exit sketch and delete that. And let's just make a sketch in the right plane. That's probably what we should have done in the first place. So right plane. Let's make a circle about here. Make its diameter 40. And then we'll say center point, line, make them pierce, bead in the string. Now we'll go to feature sweep. We got the circle as the profile, and then we'll select this as the line. We obviously want it to go both ways, so we'll select bidirectional. And that'll be your first half of the top sweep. And now for the second half. And make sure to start a new sketch for every sweep so you don't confuse them. So go back to the front plane. And well, here it's pretty self-explanatory. It'll just be a straight line. But I think See, when you look at the drawing, if you look closely, you can see that the top half, the top bar seems to kind of be like, it's like extruded inside of this part of the pipe and then this part of the pipe. So you wouldn't want to draw a straight line just connecting these two edges. You want to go a little deeper. So we'll go a little deeper. I think we can go like this. Like this. And I'm just going to constrain the endpoints to these top edge midpoints, if I can find them. Let me actually just attach points there. This point tool does come in handy sometimes. I thought it was useless at first, but it's actually pretty useful in certain situations. But anyway, we'll make these vertically constrained. Same with this. Vertically constrained. And now we just gotta control the height. And its height, distance from origin, will be 572. Now you have a fully defined sketch. And now, just like before, we'll exit the sketch. Draw, or I hate how it keeps on automatically doing that. So we'll go into right plane. And just draw a circle basically anywhere. Then make it a standard 40. Then click the center. Control click the line. Then you'll pierce bead in the string. Let's go feature sweep boss base. Click the line for the profile. Make it bidirectional. And select OK. And you see how it looks like the pipe's kind of like eating the top pipe, and that's what you want. You wouldn't want there to be any gaps, and you wouldn't want it to look too awkward either. So this is good. Now we can go on to the easy part, which is just, you know, what we're familiar with, just normal extrudes. So let's click a new sketch in the front plane. And, well, actually, first of all, let's use our center line. And in this, I'm just going to draw both. I'm just going to end up drawing both extrusions. Also, be careful because the this kind of like, I don't know, like this kind of like what do you call it? Like a closed drawing. It looks like a closed drawing board. This closed drawing board extrusion is actually a lot thicker than this rectangular extrusion here, where the slots are. So draw the closed drawing. Actually, it looks more like a Dorito chip. We'll call it a Dorito chip. The Dorito chip shape. And we will just draw half of it and mirror the rest on the other side, like so. Let's add our dimensions. Ooh, you know what? I made a fatal mistake. I quite literally just broke my own rule. Literally the thing I just talked about. Remember when I said when you're making extrusions inside of extrusions, you want to make sure that the sketches that you're drawing kind of intersect each other. So let's do that again. So let's draw a horizontal line like this. and then see, now it's in the middle of the sweep that we created, and then we'll create a vertical or diagonal line more or less in the middle of the sweep, and then we'll finish it off with a horizontal line. So now it's kind of embedded inside the extrusions, so this is good. And then, like before, we'll do mirror tools. And obviously the reason why we're doing this, why we're extruding the sketch, or drawing the sketch intersect the inside of the previous extrusions, is so that we don't have any kind of air pockets by the time we're done with the extrusion. It tends to look very awkward. Okay. So this bottom edge right here has a width of 175. The distance from origin to top edge should be 475, and yes, that is the same dimension we used for this profile right here, the pipe profile. And then, is that fully defined? No, that's not. Wait, hold on. What else do I need? 475, 175. Oh, how wide should it be? 275? 275. Is that 275? That must be. Wait. 175, 475, 175 for the bottom edge, 475 total height. Total height 275. I believe this line. Oh, yes. 275, yes. 275. Okay, sorry. For some reason in the let's see. In the like the broken view where it like separates the sweeps, I confused that 275 as being the distance between the slots, but that's actually not the case. It's actually indicating that this width right here of the top edge of this Dorito extrude. So that's fully defined. So let's draw the next sketch. Here we don't need to trace the line. We can actually use a little cheat code and use convert entities and simply just convert entities. But, ooh, wow, this is a perfect place to use a little trick. I'll show you in a second. So we'll convert all the entities of this inner, of this inside. Select OK. So now all those entities are converted. Now you may think that you want to extrude this, but you know, like just like we said before, we kind of don't want to do that. See, from here it looks perfectly fine, correct? But you also have to understand that this part is just going to extrude forward. But the problem is that this cylindrical extrusion, which is a part of the sweep, it's like curving away from it. So this is going to be curving away while this is just extruding forward. So what do you think is going to happen? There's going to be a really big or noticeable air pocket right here, and you have like an just a bad part essentially. So here we need to also do intersect this, embed the sketch within this extrusion, and the perfect way to do that is use offset tool. So we use offset entities, and I'll select what we just converted, and you can also choose any value you want. In this case, I'm probably... does 10 sound good? We might as well go a little deeper, just to make sure. 20. 20 sounds very good. Yes, 20 sounds very good. So select OK. So then, I believe that's fully defined. The only thing we need is the slots. So we'll create one slot, and then we'll mirror this slot onto the other side. Select OK. Now we can finally add our dimensions. Well, actually yes. So let's dimension the distance from center point of the slot to origin. I can't even click the origin. So that distance is going to be 523, and both slots move at the same time because they're symmetric. And then let's see. Yes, the distance between the inner centers of the arcs is going to be 120, and then the distance between their centers is going to be 50. The dimensions are kind of hard to read on the engineering drawing. The drawing is like kind of fuzzy a little bit, and the dimensions are really congested. Kind of makes it hard to read. But anyway, the last dimension is the distance between these two lines, or the height of the slot is 35. Is that fully defined? Yes. Okay, that is fully defined. So now we are going to do our extrudes. So we'll go to feature, extrude by space, and we'll have to extrude it mid-plane extrude, and we'll have to do this 2 times. So let's start with the Dorito chip. The Dorito chip is extruded a depth of 22. Select contours and just a Dorito chip. Select OK. So check for any pockets. See how it like perfectly kind of it goes through the sweep without actually kind of breaching it on the other side. No air pockets whatsoever. This side too is perfect. And then we'll finish the extrude by space, go to the same sketch, do the other side, but this time it has a thickness of 6. It's much thinner than the Dorito. Oh, let me select. Oh, no. Wait, what? Yes, that's what I wanted. Excluding these 2 slots. Yes. So mid-plane extrude, 6 millimeters, everything except for the slots. So select OK. Now let's check for air pockets. Oh, perfectly snug in there. Perfectly snug. No air pockets whatsoever. Perfect. Oh my god, I'm popping off. This is crazy. Okay, now all that's left are fillets. So let's go to fillets, R5, R5 all fillets. So basically any edges you see, so this edge, top edge, was select OK. I want to do the same thing for the other side. This edge and top edge, select OK. And all along this edge and the bottom side too, both sides, and then the opposite side, like so. Select OK. I was doing them like one at a time just so it doesn't get too congested. Also, sometimes they can like cause your computer to like basically blow up. And don't forget our, can I even, yes, this edge right here, well, actually covers the whole side, that's nice. And with the same thing over here, should wrap around completely. And then the underside, like so. And the very bottom, like so, wraps around nicely. I think that should be it. Yeah, I see that my frames just dropped. Yeah, that should be it. Should be it. Like OK. Show me your completed parts. So let's go to evaluate mass properties, and you'll be getting an answer of, oh my god, it's a big number. Can't even, oh my god, wait. 4, 6. Okay, you should be getting an answer of 4,764,089 cubic millimeters, which is the correct answer. So I hope you learned something from this video, and I'll see you in the next one.